Good morning, welcome to my laboratory. I guess I haven't really explained this setup here. This is the easiest way that I've found to wire up the Ainsley single MOSFET Quantum 17 circuit. And so what I'll do now is I'll explain it. This of course is the white pegboard, very important to have that. Here's the MOSFET on its heatsink. This is an IRF PG50 MOSFET. Gate is the white wire, drain is the red wire, source is this dark wire, which is actually very dark blue, although it looks black. Okay. This here is the gooseneck that goes to the load, which is right there. Two wires in there. Here's the battery and main filter capacitor and the current and voltage monitoring and the Arduino intervalometer that controls the still camera for the data recording and logging. Okay, but oh, and this is the gate current booster, which I can use to boost the gate current or not. And then these wires here are the wires that would hook up the gate current booster to the gate of the MOSFET if I use them. Okay, so now I'm going to explain what all this is. So let me get a little bit of a close-up here. This is pretty good. All right, so this is the positive rail end here. So I'll hook up the positive supply to this little loop which connects these two blocks of the junction here. The power goes in to the load, comes back out the load, and then goes through this big loop here to the drain of the MOSFET. Comes back the source of the MOSFET, and then here where the source goes in, you can see that I've got the black lead from the current booster in there, and then there's also this little connection loop here that connects the source to the current viewing resistor. This is a 0.25 ohm current viewing resistor made out of 2.5 ohm precision CVRs hooked in parallel. So out the source, through that little loop, to one side of the current viewing resistor, to the other side of the current viewing resistor, and then this loop here is the negative rail of the circuit. Okay, so I can hook up, so that's the whole circuit. So I have places where I can hook up the positive wire coming in from the battery, the VBAT scope probe here, and then on this side of the load where I have the MOSFET drain hooked up, I can hook up the scope probe for the drain signal. Then here's the MOSFET gate, this white wire coming in. So the MOSFET gate is this little loop here and the yellow wire that goes over to the gate boost circuit if I use it. So this little loop here then allows me to hook up the function generator's red lead to the gate of the MOSFET, or I can use the gate boost circuit over there. Alright, and then this loop over here is of course where the current sense probe, or VCSR, VCVR probe goes, and on the transistor side of the current sense resistor. And then on the negative rail side of the current sense resistor, all of the scope references and the negative battery hook up there. Okay, so I'll go ahead and hook in those probes now. Let's see if I can figure this out. Okay, so the positive battery or power supply hooks up there. Right, there's all the probes. Here they are. Here's all the probes. Okay, so the VBAT probe then is this one. It hooks up there, and it's Ground reference goes over to the negative rail there. Then we have the drain probe. This I can either hook up to the drain or the gate signal to the MOSFET. Right now I've got it configured for the drain, and its reference then goes to the negative rail. Then I have the VCSR probe. It goes right here on that side of the CVR, and then its reference goes to the rail. And then I have the negative power supply lead, and it goes to the negative rail. Now, that's all hooked up. Now I have the option of taking the function generator and hooking it to the negative rail and to the gate drive input here, like that, and now the circuit is ready to run. Or I can take the function generator probe and I can hook it to the Mark E gate boost circuit, and then plug in the Mark E gate boost circuit to make the connection to the MOSFET gate and drain, like that. And now the circuit is ready to go. Right? So I crank up the voltage on the power supply until we have our 36 volts about. Right? And then I add some amplitude from the function generator. And voila, there you have it. Alright, so that's the setup. The easiest way is to use one of these 12 position terminal blocks, and every one of the 12 positions except for one is used in here. Thank you for watching.